Hi everyone, today I will explain a little bit about the exercise and take more time for you to finish it. If you cannot do the first exercise, it's very difficult for us to continue the next lecture. Here's the first question. Question 1. In this has symbol, out of students in class, 60% are genius, 70% love chocolates, and 40% fall into both categories. So determine the probability that a random selected student is neither a genius nor a chocolate lover. So let's formulate. First of all, I call it the A event and the B event, and we have property of A, property of B, and property of A and B. It means that on both categories. So the question is calculate probability of neither genus or not colors. It means that A complement and B complement. So suggestion here, you consider the De Morgan rule, means that you complement and 1 minus it. So you have n probability of A union with B equal probability of A plus probability of B and minus probability of A intersection with B. So easy, just formulate the formula and use the Morgan rule. The next is question 2. Here the six side is located even 5 is twice as likely as out 5. Is even 5 is equally likely and also same for odd 5. So concept of probabilities model for single row and outcome less than 4. Easy, just count the events x, the odd 5 is y property, and we have x even 5 is twice as 2y, and since here is 6 5 that is 6 sided, so we have 3x minus 3 plus 3y equal 1 because it's a property law. So from this you can calculate x and y, and after that you can calculate this property. Question 3. Four-sided, so you can, if four-sided die is rolled repeatedly until the first time, or either it means that not means that an event number is of 10. What is sample space for this experiment? So easy, just for x1 xi to events k is depend on even is it 2 or 4, and from xi you have I from 1 to infinity with s I 1 and 3. This is one case for sample space. Another is the by string with 0 and 1. For the last element is k time. In the last is 0 for 2, 1 for 4, and previous string is 0 for 1 and 1 for 3. It is odd event, it is even event. So just presented by a set. 4. You enter a special kind of chess tournament in which you play one game with each of our 3 opponents. Here we have 3 opponents, but you get to choose the order in which you play your opponents, knowing you know the probability of winning against each. So you win the tournament if you win 2 games in a row, and you want to maximize the probability of winning. So that's the optimal to play is the weakness opponent second, and the order of play for other 2 opponents does not matter. Here you must to win by 2 games in a row. It means that 2 games continue. So you must win the first, the second, or the second, the third, and you win. So you can A3 component, you can see A1, A2 and A3. A3 component, and it's a probability for you win each of it. For example, you know the probability of win is again, and he maximum A3, A2. I assume that it means that player 2 is the weakness. So you play in second, it means that you have the A1 and A2. You win plus A2, A3. Here probability you win in this order. And if you choose A2 in different order for the first and the third, if you win is the A1, A3 plus A2, A3. Probability you win if you change the order of the second opponent, the weakness opponent. So your task, I can clear it. Your task proves that property of A1, A2 plus property of A2, A3 less than greater than property of A1, A3 plus A2, A3 with the condition that maximum of property A1, A2, A3 equal A2. etc. And number 5, So you have a sample space omega and it Dirichlet event. You can prove it by draw the Venn diagram. Here is the omega. You can divide it by Si. Here is S1, S2, S3, S4. Together it makes the full space. And event A, any. So clearly that this event will intersect with some of them. Or from multiply rule, you can that is the sum of P A multiplied P S I and it equal B A multiply sum P S I and equal P A. Since this is 1 and this because I is not dependent on HI, you can learn the next. So from this you can prove in this. Question check. It is by draw Venn diagram. Here is A, B, and C. A, B, and C. And the first reason 2, 3, 4, 5, 6, 7. We have 7 reasons. And here is the outside. So this is a 1, this minus 6 plus 6, here is a 3 plus 4 here PI is 1 plus 6 plus 2 plus 7. P is the 2, 7, 4 and 3. So when draw Venn diagram, you easy to prove this property and compare it. So this on for exercise. I will change the deadline for you and you must finish this exercise before. And the homework for you is read the week 4. In this is about conditional probability. Very important is some example. Next week I will explain about this term and give you a new exercise. You must finish this first exercise about sample space and probability loss before we can come to next lecture.